In this video series, I work through a math problem or problems each video. In one type of word problem, we are asked to find the original number given two relationships between the number's digits. For these problems, we'll be working with two-digit numbers, and the relationships can be expressed using linear equations. Let's take a look at the example. In a two-digit number, 3 times the tens digit is 3 bigger than 4 times the units digit. The sum of the digits is 8. Find the two-digit number. When solving these kind of problems, we usually use the letters T and U to represent the tens digit and the units digit or the ones digit. And we use the letter U instead of O for ones digit because the letter O can be confusing with the letter or the number 0. So we want to use the letter U so that we don't get confused. Let's take a look at the first relationship that's given to us. 3 times the tens digit is 3 bigger than 4 times the units digit. So 3 times the tens digit is T, and 3 times that is 3T, so we're going to write out 3T. Then the word is can be translated into the equal sign. Then we have 3 bigger than. This phrase can be translated into plus 3. We're going to find out what we're adding 3 to next. 3 bigger than 4 times units digit. 4 times units digit. That's 4 times u. So we want to add 3 to the multiple 4 times u, 4u. So this is the first relation we get. The next relation is the sum of the digits is 8. The sum of the digits is t plus u. And this is equal to 8. So now we have the two equations that we need to solve for t and u. If we take a look at both equations, we see that in the first equation, the t and the u are on the both sides of the equation, while in the second equation, the variables t and u are on the same side. If we're going to add the equations together, we want to have both of the variables on the same side, or and we need to match the positions up for the variables. So if we want to match the first equation, then we need to bring the u in the second equation to the other side, and if we want to match the second equation, we need to bring the term with the u to the other side. So in this case, let's go ahead and match the second equation so that the u term ends up on the left hand side as well. So we're going to subtract 4u from both sides of the equation, and when we do, we find that (3t minus 4u is equal to 3). Now, when we add the equations together, we want to match up the coefficients so that either the t or u have coefficients that are additive inverses of each other. So we can match either, but let's say we want to match u since we already have a minus 4 in this equation. So we want to end up with a coefficient of 4. So let's multiply the second equation by 4. Then we use the distributive property, and that gives us 4t plus 4u is equal to 8 times 4 is 32. Now we add these two equations together. 3t plus 4t is 7t, and minus 4u plus 4u is 0. 3 plus 32 is equal to 35. And to solve this equation for t, we'll multiply both sides of the equation by 1/7. 1/7 times 7 is 1, and 1 times t is t. 35 multiplied by 1/7 is 5. So we found that the tens digit of this number is 5. In order to solve this pair of equations for u, we need to take this number 5 and substitute it into either the first equation or the second equation. Let's go ahead and use the second equation for this problem, but the original equation. So t plus u is equal to 8. If we substitute 5 back into that equation, we get 5 plus u is equal to 8. Then we subtract 5 from both sides of the equation. And 5 minus 5 is 0, so we get u is equal to 8 minus 5 is 3. So in the two-digit number that we're looking for, the tens digit is 5 and the units digit is 3. So the number that we're looking for is 53.